For this given circuit, I want to find the Thevenin's equivalent voltage and resistance across this terminal A and B. And we can see that there are two sources here. One is a voltage source and a current source. So in order to solve the problem, we can apply principle of superposition. So we will be able to demonstrate an example of superposition as well in this problem. So to do that, as principle of superposition says, first we need to just consider one source at a time. There are only two sources here, so one source means the other source has to be inactive. So let's first consider the voltage source. So for that case, we need to make the current source inactive. That means we need to open the source from here. So as a result, the circuit becomes like this. I will draw it again. So this will be like that, and this is now an open circuit, and this is our terminal A and B. This is 10 kilo ohms, this is 5 kilo ohms, this is 5 kilo ohms as well, and this is 10 volts, like that. So now the current will flow only through this path. It won't go there because there is no return path here. So as a result, the voltage drop will be, if I can use a separate color, different color, so this one will be the voltage drop here, I don't know, something, let's say V1. That will be 10 divided by 5 plus 5 kilo ohms, 5 kilo ohms. So the current will be 1 kilo ohms, 1 milliamps. So V1 will be 5 volts. That will be the voltage drop V1, which will be the, of course, VAB. VAB will be 5 volts in this case, which is considering only, let's call it VAB1, considering only the voltage source. Now let's consider the current source, which is this 3 amps current source, and in order to make the voltage source, we need to short circuit it. As a result, it will be like that. It's a red color. Maybe I will go back to something else. So this is, I don't know, so this one, and then like that the voltage source has been shorted out like that, and this is the current source here, 3 amps, and this is our terminal A and B. 10 kilo ohms was there, 5 kilo ohms, 5 kilo ohms. So this circuit will be reduced to 5 kilo ohms and 5 kilo ohms. This will become like that, parallel. These two resistances are in parallel, so it becomes like this. And this is our 3 amps current source, 10 kilo ohms, and this is 2.5 kilo ohms, 5 kilo ohms, 5 kilo ohms in parallel. So this is our terminal A, terminal B. So we need to find VAB basically, and what we can see, this current, the current from the current source will flow only in this path, because it cannot go through, this is an open circuit here, this resistance, so no current flows through this. This current will be, I will be 0 here, no current will flow through that. So since the current direction is like that, the voltage drop will be in that direction. I don't know, maybe I will use again a different color. So the drop will be 30 volts here, and the direction we can see it is, since VAB is like that, so this will be VAB2 will be, VAB2 will be 30 volts. VAB will be same as this voltage, which we can say V2, which is 30 volts. V2 means the voltage drop across 10 kilo ohms. I can say V subscript 10, that is 30 volts, and this is equal to VAB, because there is just only, if we apply KVL, we can see that VAB is equal to V2, minus plus and plus minus in this whole loop. If we apply KVL, we can see that. So VAB2 is 30 volts. So we have considered each of the sources. So our Thevenin, which is Thevenin or is VAB, is VAB1 plus VAB2. VAB1 was they are in the same direction, the polarity, so they will just add up. So 5 plus 30, so that is 35 volts. That's the Thevenin's voltage. And Thevenin's resistance will be, we know that in order to find Thevenin's voltage, what we need to do is we need to make both the sources inactive, and we need to just see the resistance from that. So current source is open circuit, voltage source is short circuit. So this is how it is. Now we need to find what is the resistance here. This is our 10 kilo ohms. This is 5 kilo ohms and 5 kilo ohms. As before, 5 kilo ohms and 5 kilo ohms are coming in parallel, so that's 2.5 kilo ohms, and then we have 10 kilo ohms. So our circuit reduces to this. It becomes A and B, and we can now see clearly that 10 kilo ohms and 2.5 kilo ohms, these two resistors are coming in series. So RAB or R Thevenin is 12.5 kilo ohms. So that is our Thevenin's resistance. So Thevenin's resistance is 12.5 kilo ohms, and Thevenin's voltage is 35 volts for this particular circuit. That means we can replace the whole circuit. That so if we had, let's say, if we connect a resistance of, I don't know, maybe 5 kilo ohms, let's say another 5 kilo ohms across this terminal, then we can replace Thevenin's theorem. What it means is this whole circuit can be, this whole portion of the circuit can be replaced by one voltage source and one resistance. So that will be, one voltage source is 35 volts, this will be the polarity, and one resistance will be 12.5 kilo ohms. This is equivalent to that terminal, the left side of the terminal AB. Now if we connect the same resistance 5 kilo ohms here, instead of analyzing from that circuit, we can find the current through this 5 kilo ohms once connected, current or voltage drop across that, using this circuit. The whole side, left side, is represented by this one voltage source and one series resistance. This is the meaning of Thevenin's theorem. This is the meaning of finding Thevenin's equivalent at any terminal. So yeah, that's it.